Hey there everyone, it's me, Hydrogen, and today we're diving into a topic that's equal parts fascinating and mysterious, the Riemann Hypothesis. Yeah, I know, it sounds super intense, but hang with me because this is honestly one of the biggest unsolved puzzles in mathematics. Seriously, it's wild. And trust me, the journey we're about to take is so worth it. The Riemann hypothesis is one of the most profound and long-standing unsolved problems in mathematics, proposed by the German mathematician Bernhard Riemann in 1859. It concerns the distribution of prime numbers and the complex properties of the Riemann zeta function. Despite being over 160 years old, the hypothesis remains one of the greatest mysteries in mathematical theory. Prime numbers, those that can only be divided by one and themselves, form the building blocks of arithmetic. They appear sporadically along the number line, and their distribution is seemingly irregular. Understanding the pattern behind prime numbers has been a fundamental challenge in number theory for centuries. The Riemann hypothesis suggests that there is, in fact, a hidden structure within this apparent randomness. The hypothesis revolves around the Riemann zeta function, a function that takes complex numbers as input and produces a complex output. The zeros of this function are the points at which its value equals 0. While some of these zeros are easily calculated and lie on the negative, even integers, known as trivial zeros, the hypothesis concerns the so-called non-trivial zeros. Riemann conjectured that all non-trivial zeros lie on a specific vertical line within the complex plane, known as the critical line, where the real part of the input is equal to 1/2. This statement, though deceptively simple, implies a profound regularity in the distribution of primes. If proven true, it would reveal an elegant and consistent pattern that governs prime numbers, bringing a new level of understanding to one of mathematics' most fundamental concepts. The importance of the Riemann hypothesis goes far beyond theoretical interest. Prime numbers are not just abstract mathematical entities. They have practical significance, particularly in modern encryption systems. Cryptographic methods such as RSA encryption rely on the difficulty of factoring large prime numbers. Verifying the hypothesis would either solidify the foundations of such encryption or challenge the assumptions underlying current security protocols. The hypothesis has been verified for the first few billion zeros, all of which fall on the critical line as predicted. However, numerical verification, no matter how extensive, does not constitute proof. A formal proof must demonstrate that all non-trivial zeros, of which there are infinitely many, lie on the critical line. This challenge has attracted the attention of some of the greatest mathematical minds throughout history, from David Hilbert to modern researchers armed with supercomputers. Despite substantial progress in understanding the zeta function and related fields of analytic number theory, the hypothesis remains unresolved. Its proof is considered so crucial that it has been designated one of the 7 Millennium Prize problems by the Clay Mathematics Institute, with a $1 million prize for a conclusive solution. The mathematical community remains divided on whether a proof will eventually be found. Some experts maintain confidence in its truth, while others question whether it might be independent of currently accepted mathematical frameworks. Regardless, the pursuit of a solution continues to shape number theory and mathematical analysis, fostering innovation and advancing the field in unexpected ways. The significance of the Riemann hypothesis lies not only in its mathematical implications, but also in its philosophical allure. It embodies the pursuit of order within apparent chaos, reflecting a fundamental desire to uncover the hidden patterns that govern the natural world. Whether proven true or false, the journey toward resolving this hypothesis is a testament to human curiosity and intellectual ambition. Thanks for tuning in, and stay curious.